right, turn to page 722. Take out your highlighter, and now we're going to add combinations. The main difference between combinations and permutations is when you have a number of objects and put them in order, and combinations is when the order doesn't matter. So they have an example here. Consider the number of ways a reader can choose 3 books from 4 books. Okay? You win a draw and you win 3 books. And there's a table at the front which has 4 books. And you get to choose, for different books, you get to choose which books you want to take home. It doesn't matter the order you pick them, you still get 3 books to take home. It's not like you have to arrange them on a shelf or anything yet. You can worry about that when you get home. So when the order doesn't matter, we can look at one combination is you could pick book 1, 2, or 3. However, permutations would give you 6 different ways that those books could be arranged, but in combination that's only counted once. Another combination of 3 books, you could pick book 1, 2, or 4. In permutations, there would be 6 of them, but in combinations, it's only counted once. All 6 of those are the same. And same thing if you picked 1, 3, and 4, and 2, 3, and 4. There's only 4 combinations. Meanwhile, there's 24 permutations. So one of the ways of imagining a combination is you first think about the permutations. And for permutations, I'd probably do spaces. If I was ordering 3 books from 4, how many choices would I have for my first book? Any of the 4. How many for my second? 3 left, then 2, to give me 24 in total. But a permutation gets rid of the order. So how many ways can you order 3 things? 3 factorial ways. Notice that there are 6 in each of these, because if you have 3 books, 1, 2, and 3, and you wanted to arrange them on a shelf, that could be done in 3 factorial ways. So permutations and combinations are related in that a combination is just the permutation with the order divided out. So we divide by 3 factorial. The combination formula then says take your permutations formula, I'll highlight it right here. Combinations formula says take your permutations formula and divide out the order. If we want to see what that looks like on our formula sheet, it looks like this. N choose R is n factorial over n minus r factorial divided by an extra r factorial. You might want to remind yourself here and put the NPR formula as n factorial over n minus r factorial. And you know how we hardly use the NPR formula? Because we could do things with spaces instead. With combinations, we use the formula a lot. For this year, the notation that we generally use is this NCR. Next year in your IB course, you will use this notation more with an N and an R in brackets. Kind of looks like a fraction, but there's no line in between. Okay? Now for NCR, I like to read it as N choose R, because when you're choosing things, the order doesn't matter. And NPR is N pick R or N place R. Placing sort of seems to imply that you have an order. The big difference between them is that combinations have no order and permutations do have order. Okay? So let's go to example 1. A lot of lotteries don't matter what order you have. If you pick the right numbers, but in the wrong order, you still win the big prize. So here's one lottery, Keno lottery. That's one I'm not as familiar with. But if you play it, you pick 20 numbers from 80. How many combinations are possible? If the order doesn't matter, it would be 80, choose 20. So again, we need to find the choose button on our calculator to see how big of a number this is. Same place where we found our exclamation mark. Hit your math button, go over to probability. The third one is combinations. So you can do 80, choose 20. 3.53 times 10 to the 18. Which is a huge, huge number. So your chances of getting the right 20 numbers are very, very, very slim. Probably in Canada, a more common lottery is Lotto 649. How many of you have heard of that? Yes? Do you know how it works? The Lotto 649, those numbers are there because there's 49 numbers, and if you choose all 6 of them right, you win the big prize. Okay? So, how many different possibilities are there? If you wanted to, you could guarantee yourself that you could win. You would just have to buy every single possibility. How many possibilities are there? Well, if we do 49, choose 6, order doesn't matter. Go to our calculator, find this out. 49, not random. 49. Choose 6. 13,983,000. 816 or 916? 816. So if you went out and bought almost 14 million tickets, you would guarantee that you're going to win the lottery. Okay, what do tickets cost? Usually $6.
Well, it depends if you get like the extra.
Oh, if you get all the extra stuff. But I think if you just buy the numbers, I think it's as low as $2, right? So as low as $2, okay, 2 times 14, for as little as $28 million, you could guarantee that you're going to win.
How much will you win?
Well, it depends what the prize is. Sometimes it gets big, right? When it's 60 million, you just have to go to your bank and you say, hey, could you borrow me $28 million? And they would be like, why? And they say, I'm going to win the lottery.
Why hasn't anyone done that?
Well, there's a couple of problems. Okay? If in the $60 million prize you do that, and 2 other people happen to win as well, then you split it. 60 million split 3 ways is 20 million. And then you're only out $8 million and say to the bank, you know what, I'm sorry. Will that be okay? I don't think it'll go over very well if you did that. And that's probably the reason why no one's done that or collected, or a bank hasn't decided that they're going to guarantee win. Because as soon as it gets split, then there's a problem. Okay? So your chances of winning are 1 in 14 million if you buy 1 ticket, which is super, super rare. But people win, right? Why do It's not guaranteed that someone wins, but people do win. And the reason that people do win is sometimes they sell over 14 million tickets. And not guaranteed that everybody picks a different number, because some people pick the same number. But once you get enough tickets sold, then the chances that someone win becomes plausible. If only one person buys a ticket, the chances of winning are so astronomically small, the chances are they won't win. In fact, that's true for everybody who buys it, but every once in a while, someone gets super lucky and wins. Okay? Now, if you want to get a sense of how likely this is, let's see, I think it's, there we go. No, 2 to the 22. No, 2 to the 23. Let's see, I'm trying to get close to that number. 2 to the 24 is too much. Okay, 23 times. Flip a coin 23 times. If you get heads 23 times in a row, and don't use a double-sided coin because that'll throw your, but a real coin with heads and tails. What are your chances of flipping a coin getting heads 23 times in a row? Likely? Have you tried it? Okay. Let's see if I have a penny. This is rare. I'm willing to sell this for a toonie after class if anybody wants. Right? I got heads. Okay. 1 for 1.
22 more to go. Please just lie.
Oh, tails. So then you start again. And you do this for out tails, so start again. Oh, 2 tails in a row though. Oh, heads. Start again. 2 heads in a row. No, tails. 2 tails in a row. Heads. Okay. Tails. Tails. 2 tails in a row. Oh, heads. 2 heads in a row. 3 heads in a row. Tails. And you only need to get 23 times in a row, and it's still going to be less likely than winning the lottery. Okay? So chances of you winning the lottery are very, very little. Okay? So do not buy a lottery ticket if you think that giving that $2 is going to make you win. However, if the $2 that you spend gives you the best imagination fantasy that you've ever had, like imagine what I would do with all that money. And you can imagine all the way up to the draw when you lose. Okay? But that you can't imagine what it would be like to win the lottery if you don't buy the ticket, right?
You can win $20
Sometimes, but that's not that exciting. Right? But winning it all, right? So for that $2, if that fantasy was worth $2 for you, then perfect. But if you were banking on winning the lottery when you buy that $2, that is, know that you will lose money every time you buy lottery tickets overall. General consensus, you buy lottery tickets, you're going to lose money mathematically. That's how it's set up. Otherwise, they wouldn't make any money. But if that fantasy is good for you, then perfect. The British lottery recently changed it from Lotto 649. Theirs is Lotto 659. So now your chances of winning are even less. But as a result, the price of the ticket is the same. The prize is bigger fantasy for $2. And if you get one number right, you get a free ticket so that your fantasy can last another whole week. Eventually you lose. What are the odds of getting one right? That's a good question.
What if you buy 30 tickets and then you get all 30 of those? Like you get the same number, and then that number's right, so you get 30 new tickets.
Yeah. And then eventually you lose, but that's okay. But this is the idea of lotteries. Okay. So this penny was a very rare 2010, right? Chances are it will be worth more than $2 tomorrow. So if you want to buy it for $2 today, you just come see me after class. I shouldn't have that on video. Oh well. Yeah, I was trying to con my students. Because you just have to 59 choose one.
So wait, for these questions, do you ever learn how to solve it algebraically?
Yes, eventually.